An Introduction to Complex Numbers by John Gillis. This lecture explains how the set of real numbers and the real number line is enlarged to include further numbers called imaginary numbers and complex numbers. The set of complex numbers is a natural extension of the real numbers, and the complex numbers enable us to solve polynomial and other types of equations that have no real number solutions. This lecture is divided into two main sections. Section 1 introduces the complex numbers as a set and how the numbers are represented graphically. Section 2 shows how the basic arithmetic operations are defined on the complex numbers and how algebraic algorithms are consistent with the set of real numbers. Section 1, the set of complex numbers. In this section, the imaginary unit and the complex numbers are defined. Plotting numbers on the complex plane is illustrated. We begin with the imaginary unit I. Consider the quadratic equation x squared plus 1 is equal to 0. In order to solve this equation, we must subtract 1 to both sides, and then take the square root of both sides, resulting in plus or minus the square root of negative 1. Since there are no real numbers that can be squared to give you negative 1, the square root of negative 1 is not a real number. We define the imaginary unit I to be the square root of negative 1. Keep in mind that if I is equal to the square root of negative 1, then I squared is equal to negative 1. If we now place I back into the original equation, x squared plus 1 is equal to 0, we obtain the following true statement. Therefore, both I and negative I are solutions to that equation. In general, any real multiple of I is considered to be an imaginary number. The following are some examples of imaginary numbers. The set of complex numbers. Complex numbers are formed by combining both real and imaginaries together by adding or subtracting. The standard form of a complex number is a plus bi, where a is the real part and bi is the imaginary part. The following Venn diagram shows the set of complex numbers as sets. Notice that real and imaginary numbers are both subsets of the complex numbers. Also notice that 0 is the intersection between real numbers and imaginary numbers. In order to graph complex numbers, we require two dimensions. Think of the x-axis as being a real number line and the y-axis as being an imaginary number line. We can graph complex numbers just like ordered pairs, where the x-coordinate is the real part and the y-coordinate is the imaginary part. The following are some examples.